Okay, wonderful. So the last thing I want to do today is walk us through other ways that markets can be linked through general equilibrium effects. So I'm going to start by thinking about situations where markets are linked through demand, meaning that the price of one good affects the demand of a different good, right, because they're complements or substitutes. And then I want to think about links through supply. So situations where the supply of one good, the amount of one good produced, affects the price at which some different good can be produced. I'm not going to do this mathematically, right? We're not going to work through the algebra of these problems again. I just want us to get a deeper intuitive understanding of what we're doing when we're doing general equilibrium effects. Okay, so why don't we start by thinking about links through demand? And why don't we go back to the example of Zolifil and Yeslinti, right? Which we said are these two different drugs that are perfect complements. Right, so we're going to say Zolifil and Yeslinti are complements. And we worked out in our problem set, right, some demand curves for Zolifil and for Yeslinti. We said something like the quantity demanded of Zolifil at a price X and price Y equals 50 over 5px plus py. And the quantity demanded of Yeslinti for px and py equals something like 10 over 5px plus py. Right? So the important point here is that when the price of Zolifil goes up, demand for Yeslinti goes down, right, at any given price px, py. When price of Yeslinti goes up, demand for Zolifil is going to go down, right, because these two goods are complements. Cool. Let's imagine that, to start with, we're in a general equilibrium, right? All of our markets are in equilibrium, with a price of Zolifil equal to 1 and a price of Yeslinti equal to 1. Cool. So if we graph this, right, we would have for Zolifil some demand curve like this, right? Right, it's going to show us how much Zolifil we're going to buy at any price px, given that the price of Yeslinti is held constant at 1, right, along with our income and our preferences and all the other stuff that affects demand. And then I'll just draw some upward sloping supply curve. That just depends on the price of Zolifil. And we'll say that we're in equilibrium at a price of 1. Cool. I can do the same thing for Yeslinti. Right? Where again I can draw some demand curve. It's going to tell me my demand for Yeslinti at any given price. Py, holding px constant at 1. And again, I'll just draw some arbitrary supply for Yeslinti. That only depends on py. Great. So just to be really clear about what we're doing, right? Our demand curves are telling us, holding everything but the price of Zolifil constant, including Yeslinti, right? How much Zolifil would we buy at any given price? Holding everything constant except for the price of Yeslinti, how much Yeslinti would we buy at any given price, including holding the price of Zolifil constant. This should catch the axis. Being a little perspective. Okay. So far, so good, right? And we've asserted, right, that we're in a general equilibrium here, right? So that there's no pressure on either of these two markets to change. Now let's think about what would happen if we had an increase in supply of Zolifil. Right? Supply of Zolifil increases. So we can graph this, right? Something like this. And then we can look at our graph and we can say, oh, we'll have a new market equilibrium here, right? Where supply equals demand. There will be some price, I'll say 50 cents, just making up numbers, right? There will be some expansion in demand. Cool. The only problem is, what's going to happen to our market for Yeslinti when we have a decrease in the price of Zolifil? right? The price of Zolafil falls from $1 down to 50 cents. Well, what we expect, right, is that our demand for Isplinti is going to increase, right? Because Zolafil and Isplinti are complements, right? So this is going to have an effect. It's going to increase demand for Isplinti. Right, we'll have a new demand curve for Isplinti, where at any given price of Isplinti, we're going to demand more, right? Because the price of Zolafil has fallen. Right, we can draw a new demand curve that tells us how much Isplinti will buy at a price when Zolafil has a price of 50 cents and Isplinti has a price of PY. Cool. So what do we see happens? Well, when demand for Isplinti goes up, right, we move along our supply curve, which is upward sloping. As a result, we're going to end up with a higher price of Isplinti than we had before, right? An increase in the price of Isplinti. I'll say it is something like $1.25. So this is going to increase the price of Isplinti. Well, what happens to the Zolafil market when I increase the price of Isplinti? Well, what we know, right, we know that when the price of Isplinti goes up, our demand for Zolafil is going to go down, right? If this is our demand for Zolafil at a price of 1, at a price of $1.25, we're going to ask for less. So we'll have some new demand for Isplinti, for Zolafil, that's going to be less, right? QDX, PX, PY equals $1.25. And as a result, right, instead of having our quantity increase here, right, I'll say Q1, our quantity is only going to increase to here. And instead of having our price fall to 50 cents, our price will fall a little more, let's say to 40 cents. Does this make sense? So what we're going to say, right, is if we wanted our demand curve to reflect not just what happens when the price of Isplinti is constant, but instead what happens when the change in price of Zolafil plays out in the Isplinti market, right? So if instead of holding the price of Isplinti constant, we wanted to hold something like supply and demand of Isplinti constant, right? We would predict that this increase in supply of Zolafil would have a smaller effect on quantity and a larger effect on price than we would think it would if we were only looking at the partial equilibrium picture, right? If we weren't taking into account the effect on the price of Isplinti. So if we wanted to draw something like our general equilibrium adjusted demand for Zolafil, right, our demand for Zolafil holding the Isplinti market constant, instead of holding the price of Isplinti constant, it will be significantly less elastic right, our general equilibrium graph would be less elastic than our partial equilibrium graph, right? Because of the fact that the effect on quantity of an increase in supply of Zolafil is muted by the market for Isplinti. Great. Okay, so I just want to throw one last thing at you and then I'll let you go. So we talked before, right, about the relationship between a product market and an input market, right? The relationship between the market for avocados and the market for farm workers. We said that these are linked because if we want to increase the number of avocados we grow, we have to increase the number of farm workers we employ, right, which is going to raise the wages of farm workers. So the last thing I want to do, right, just to get in pictures, is to think about the way that these markets will be linked if instead of just considering an input market and output market, we wanted to think about two output markets that share an input. So let's imagine, for example, that we're talking about the markets for avocados and for strawberries, right? Both are grown something like, in the Central Valley, right? Using similar land, right? Similar soil and climate and all this stuff is good for avocados and strawberries. So we might think that changes in the avocado market might affect the strawberry market through their effect on the market for land and vice versa. Okay, so to write this out, let's imagine we've got a market for strawberries, right, where we've got demand for strawberries that we're going to assume is just a function of the price of strawberries. And we've got supply of strawberries that depends on the price of strawberries but also depends on the rental rate of land, which for now, let's say is $1 an acre. Right, we've got an avocado market, same deal. Where we've got some supply of avocados that depends on the price of avocados and the rental rate of land, we'll say is 1 for now. And we've got demand for avocados that just depends on the price of avocados. Right? So again, right, what we're doing is we're drawing partial equilibrium supply and demand curves here that say if we held the rental rate of land fixed along with everything else except for the price of avocados, how many avocados would be supplied and demanded at any given price? Right? If we hold everything fixed except the price of strawberries, how many strawberries would be supplied and demanded at a given price? Then the last thing I want to draw out, right, is our market for land. Right, where we have some rental rate R. We've got some quantity of land. Right? Say I've got a supply of land like this. It's going to be a function of the rental rate of land only. And then I've got demand for land. That's going to be a function of the rental rate, but also the number of strawberries and the number of avocados that I'm consuming. Right? Because this demand for land is coming from, right, demand from the strawberry industry and demand from the avocado industry. So this is going to depend on the quantity of strawberries equaling Q at S1, demand the number of avocados equaling QA1. Cool. Okay. So then what we want to know, right, is if this is an equilibrium right now, how are these markets going to interact with each other if there's some change, right? So let's imagine, right, we all discover the glory of avocado toast. We have some increase in demand for avocados. Right? So what's this going to do? Well, if we have a higher demand for avocados, we're going to grow more avocados, right, at a given price, given rental rate of land. So if we grow more avocados, that's going to increase our demand for land. Right? Increasing our demand for land is going to increase the price of land, right? It's going to increase the rental rate. What's that going to do? Well, it's going to mean that in the in the strawberry market, right, now that we have a higher rental rate of land, we're going to supply fewer strawberries at any given price. Right, let's say R equals 1.5. Right? What happens when we have a decrease in the supply of strawberries? Well, that's going to result, right, in fewer strawberries being grown, therefore a decrease in demand for land. Right? Which is going to bring the rental rate of land down a little bit from where it would have been if we just thought about the effect of the avocado market. So what's going to happen in the avocado market? Well, we're going to have a reduction in supply of avocados, right? Because this is the supply when the rental rate is 1, right? We're going to end up with a rental rate that's still above 1. But it's going to be a little bit less than the reduction we would have expected, right, had we not considered the strawberry market, right? The equilibrium effects of the strawberry market were to dampen the increase in rental rate there. Cool. So we'll end up with some new equilibrium that's somewhere like here, instead of where we would have expected it here if we hadn't considered any of these general equilibrium effects, or somewhere like here if we hadn't considered the effect of the strawberry market. So if we draw our general equilibrium product supply here, right, it's going to end up being a little bit steeper than our quantity supplied, not considering general equilibrium effects, because of the fact, right, that as we increase the quantity of avocados, that's going to increase our price of land. But it will be a little bit less steep than it would be if we didn't consider the general equilibrium effects of strawberries, which dampen this effect on the land market. Okay, cool. So big picture, what are we doing, right? What's the takeaway from today? The big takeaway from today, right, is that we want to be careful about when we're able to assume that what happens in one market doesn't affect relevant rental rates, prices, quantities, etc., that in other markets, right? So we're going to have a different story when we consider partial equilibrium, where we hold everything except the prices and quantities of a specific market fixed, than we will in a general equilibrium, where we consider the ways that markets interact with each other, right? Where instead of holding other prices constant, we're going to hold something like other supply and demand in the related market constant. Okay, great. Thank you so much for sticking with me. I'm looking forward to talking to you about all of this soon.